So this video is to show how to transform a function ax squared plus bx plus c. So it's a general form quadratic where we don't have values for the coefficients, we're just using a, b, and c. But we're going to transform that using the technique of completing the square into the equivalent function in vertex form, so we'll be able to extract what the vertex is. But then in addition to that, we're going to use that vertex form to then solve the equation and find out where this function equals 0. So we're going to start, as usual, by factoring out the leading coefficient. So, in an actual problem, a might be 1 and you didn't have to do this step, but we don't know what a is. So we're going to do this as if it's whatever. So I factor that out. A times x squared is ax squared. A times b over ax is bx. And then I like to kind of have the c, the constant, off to the side. So then in my next step, I know that half of b over a, so a half of b over a, 1 times b is b, 2 times a is 2a. A half of that coefficient is what has to go in this packet. And so in a sense, I already know h. I'm trying to look for this h, and I know that h is the opposite of that, is negative b over 2a. Just that first little bit, and I know the x-coordinate of the vertex of this parabola. But going back to where I was, the coefficient is b over a. I know that's going to be double what's in the packet, and so I just cut it in half, a half of that, and I'll get the constant in the packet. But now I need to figure out what goes here. So I don't know what constant is going to complete that perfect square trinomial, but I know that it's always the square of my h. Well, not my h, but the square of my constant that I put in the packet. So if I square b over 2a, b times b is b squared, 2 times 2 is 4, a times a is a squared, so I'm going to add b squared over 4a squared. But I got to subtract it right immediately after adding it. I can't really change the value of my function, so I needed to have these three terms to then form that packet all the way, because that trinomial, that perfect square trinomial, factors into the square of that binomial. But I need that other piece, that other term, to make sure that I didn't change the value. I had to add b squared over 4a squared. I need to subtract b squared over 4a squared. But now I've got a problem, because all of this stuff is what I need for the beginning of this vertex form. But this guy right here isn't part of that. So I need to get it out of the parentheses. So I need to make sure I distribute that a times that piece. So I'm going to say, all right, what the heck is a times negative b squared over 4a squared? And what's interesting here is I've got an a and an a over there, so that comes out to negative b squared just over 4a. So that's what's going to come out of here, negative b squared over 4a. The c, that's still c right now. That's still just c. And I want to simplify this, so I'm going to have to combine these two terms. Over here I've got the ax plus b over 2a squared. That part's fine. I already have my h is negative b over 2a. That's cool. But these other two terms, the minus b squared over 4a plus the c, I'm going to have to get a common denominator. So it looks like 4a is what I need to put on this c over 1 to give it the right denominator. So my minus b squared over 4a plus 4ac over 4a. All right, this is looking good. At least I have a common denominator, 4a. And what do I have? Minus b squared plus 4ac. Okay, and so that was added to this other stuff. So this is great. I now have k. So there's no room. I'm going to erase some of this other stuff over here. So hopefully you copied that down. If you didn't, then you can rewind. But I'm going to erase this stuff. That's great. This is actually feeling like erasing. So I go over there and I say, okay, so my h was negative b over 2a. My k looks like negative b squared plus 4ac all over 4a. All right, we're getting somewhere. So let me write this down on the next piece of paper. So our function right now should be in black. F of x is a x plus b over 2a quantity squared plus this funky fraction minus b squared plus 4ac all over, and let me just check, all over 4a. I'm going to solve for where this is equal to 0. And so this is going to be interesting. What I want to do is keep this on the left-hand side, and then I want to subtract this big crazy fraction. So it's added right now, so I'm going to want to subtract it to get it to the other side. But if you think about it, subtracting that whole thing is just going to be the negative of that, because I have 0 minus that. Oops, don't want red. So I've got 0 minus this crazy thing, b squared plus 4ac all over 4a. All right, but it looks like maybe I can pass this negative sign in there. So let me try that. So it's the opposite of a fraction. I could put that negative just on the top if I want, and I think I'm going to do that. So 4a, I'll leave 4a, but I'm going to put that negative on the top. And then distribute it. So negative of negative b squared, that's b squared. Then negative of 4ac is minus 4ac. So this is where we are. So we've got a times x plus b over 2a quantity squared is b squared minus 4ac over 4a. Let's go to the next page. I don't have any room over here. Or actually, let's do one more step. I'm going to multiply both sides times 1 over a. What that does is that kind of schwack up here. So I've only got the packet, the x plus b over 2a squared. So I've got just the packet. I multiply by 1 over a, so the a is gone. Now it's on the other side, and I have, in the denominator, I have a couple of a's. I have 4a squared. So I've got my b squared minus 4ac over 4a squared. squared. Now I'm going to use this little trick that when I'm trying to solve something where I've got a packet squared equals a number, and that's what I've got, I'm going to look at square roots. I'm going to go, what's inside this packet is going to be plus or minus the square root of b squared minus 4ac all over 4a squared. And so this is getting somewhere. We almost have what x is, and in fact I think we can get x if we just take away b over 2a from both sides, so that x is negative b over 2a plus or minus the square root of b squared minus 4ac over 4a squared. But we can clean this up. We can clean this up a little bit. Because if I think about it, I can say that the square root of a fraction, that I'll have to rewrite, is the square root of the top over the square root of the bottom. For example, the square root of 16/9 is the square root of 16 over the square root of 9, for example. So let's back that up. That was just my little example. I don't want it cluttering the board. So let's see. All right, what is that? So square root of b squared minus 4ac, I don't have any idea. But the square root of 4a squared, well, 4 is a perfect square. That's just 2. And a squared is a perfect square of a. So we'll get into making sure we don't do anything mathematically cruddy later in this semester. But right now, we can kind of say that this minus b over 2a plus or minus the square root of b squared minus 4ac, down here in the denominator we have the square root of 4a squared. Well, square root of 4 is 2, square root of a is a. Why don't I just call that 2a? And how convenient is that? Because we have a common denominator. And you might recognize that as the quadratic formula.